Okay, hi guys. So since I'm out today, we are going to have a research methods day, which is really helpful when we're starting to do more and more study evaluation to make sure that we actually know the terminology that goes with it and our evaluations are correctly using kind of psychology terms and so forth. So today we are going to do the first couple of pages. So you should have already done these definitions for homework. So we're going to do the bottom of here and this chart, and if we have time we might move on to experiments as well. We'll pick back up, remember, on Tuesday next time I see you tomorrow. We are going to do our chatting, our little tea break about social cognitive theory, and then we'll pick back up with stereotypes. So research methods are kind of standalone lessons that go across all of the different topics. So we did some of this during transition, so it should be some of this familiar, but we probably want to go into a little bit more detail now and have it kind of officially in our research methods book so you can kind of refer back to it. So what I want to do first in this first chart here is just really clearly establish what each of the methods are that you would need to talk about, because you will get questions on exams that are like, describe the research method used in one study, and it's really important that you're using the correct method and describing it that way. It also makes up a big component of paper 3, which is HL only, so really important there, but even for SL, just understanding what the methods are and what makes it that method is really important. So I'm dividing them by qualitative and quantitative, and I'm using the division that the IB has divided them into. So quantitative. So these are research methods that gather numerical data, and then qualitative methods. And so these are research methods that are gathering descriptive data. So we can kind of add that in if you just want to add kind of underneath it. What makes it quantitative is that the data that is gathered should be numerical. So you can think, am I getting a number for each group? And if we are looking at qualitative, we're getting kind of worded descriptive data. So if you think, I don't think there's any particular way that could be simply given us numbers, then you're looking at more likely to be qualitative. So it's a decent start. It's not super clear because there are ones that kind of blur the lines a little bit, but it's a good way to start with. So we're going to do 3 in each, which is how the IB has kind of broken it down. So 3 quantitative, 3 qualitative. So the most important quantitative, which is what you're going to have to be writing about the most of the time, is an experiment. So experiments are considered to be a quantitative method, because generally speaking, the goal of the experiment is to gather numerical data. What makes it an experiment, and this is going to be really important because there's a lot of different ways to gather data, but what makes it an experiment over the other methods is that there is a believed independent variable. So we are testing something. So we think this causes an impact on this. So if you can clearly identify an independent and dependent variable, this is the cause, this is the effect we're looking at, you're probably looking at an experiment. Whether that IV is manipulated or not determines the type of experiment. How the data is gathered is a separate issue, but if you're like, this is clearly attempting to look at one factor's impact on another, you're probably looking at an experiment. So we're going to clarify, because we don't want to use the word manipulated because that's only true of true experiments. So we're going to say if it's an experiment, it is measuring how the independent variable impacts the dependent variable. So to make the distinction with where we're going to go next, it's not just any two variables. There is a clear one that is believed to be cause, one that is believed to be effect. So that's kind of the distinction, is that there is something that we believe is more causal. Doesn't mean we can determine cause and effect, but it means there is one thing that is the one having the impact, and there's another thing that is the effect. So there is a distinct difference between those two variables. Okay, so there's some sort of attempt to say this on this. Whether or not that is manipulated depends on the type of experiment. So if it is a true experiment, the IV was manipulated by the experimenter. We're going to talk more about that when we talk in more detail about experiments. And the key I'm going to teach you then is, was there allocation? So could you say, you go to this condition, you go to this condition? If your IV is age, I can't be like, you be old, you be young. It's a pre-existing thing. So could I allocate you to conditions? If I, as an experimenter, could put you in a group, it's a true experiment. If I couldn't put you in a group because your group identity came with you, it's not a true experiment. So true experiments, the IV was manipulated. So those are the best to write about if you're choosing a method to write about. The other two types of experiments, the IV is not manipulated, which are quasi-experiments and natural experiments. In both those cases, it was not manipulated. We're making use of naturally existing groups or situations. So they're still trying to measure an independent variable. The only difference is the independent variable is not something that we can actually manipulate. So gender would be a really good example. So still saying, I think gender is the IV and IQ score is the DV, but the gender is going to be a naturally existing category. So that's already exists, and then I'm just going to test its impact. Okay, so those are our experiments. I'm not going into strengths and weaknesses of each of these. We are going to go into more detail on all of these. Right now, we're just trying to clarify what the methods are and how to be able to tell what method you're looking at. Okay, the next one, so experiments. So what I emphasized here was that we had some sort of clear independent variable that kind of actually allocated into groups. So we had something that was kind of different conditions. For a correlational study, we are looking at the relationship between two variables, but we're not necessarily looking at an IV and a DV. We're usually looking at two continuous variables. So where do you fall on this? Where do you fall on this? So it doesn't have as clear of an IV-DV grouping. It's generally two more continuous variables. So I might add one more thing here. Generally speaking, the IV here is some sort of groups or conditions. So it's some sort of discrete. If we're looking at correlational, we're looking at two variables that are both any number of kind of things, and whether they or not there's a connection between them. So if we're doing a correlational study, we tend to be looking for relationships or associations between two variables. And generally, we're looking at two continuous variables. So a good example that we recently talked about in class was the example where they looked at like hours of violent television watched on kind of aggressive actions. So we're just tracking two things and looking for a relationship. And we just made a really good point that we couldn't actually determine cause and effect from that because we didn't really know whether it was your own aggressive tendencies impacting the TV you watch or the TV you watch impacting your aggressive tendencies. So we're just tracking two different kind of things and seeing if there's a relationship between them. It could be looking at, is there a relationship between scores on a depression inventory and kind of scores on a like family dynamics stability survey. And again, we might not know which is causing which, but we might say, oh, there's a correlation where people who are ranking their family dynamics as being really challenging also are scoring higher on this depression one. So the key here is we're not necessarily assigning cause and effect. We're just looking at, are these two factors in some way related to one another? So it's a little bit tricky when you start looking at quasi versus correlational. So generally what I would say if you were trying to decide them is if it's clear, distinct groups, then I would say it's probably a quasi experiment. If it's more of a continuous thing, I would call it a correlational. Just we'll talk about it as we go. So there is a little bit of a confusion there, but it also kind of stems with how sure are we that one is the cause versus just two things that might impact one another. Okay, the last one, so I'm gonna pull this down a little bit, that goes under quantitative is a survey. Surveys are a little bit tricky as well. The key for you to put it as quantitative is the survey has to have some sort of scale, so you're getting numerical data from it. So you are actually obtaining some sort of numerical data. Here's the tricky thing though, the survey has to be more open-ended. It has to be the whole study is the survey. If you put people in different conditions, manipulate a variable, and then the survey is how they explain how it impacted them, then your survey is simply the way you measured your dependent variable. So let's say I decided that I wanted to see whether handwriting or typing notes was effective, and I had one class handwrite notes, I had another class typing, and then at the end of the week I gave them a survey to rate how they found the experience. That is still an experiment. So I manipulated an IV, handwriting, typed notes. The survey was just how I measured my dependent variable. So I was still looking at a very clear cause and effect, and I was still actually manipulating an independent variable. If it was just I gave you all a survey that just asked you to share kind of your attitudes towards social media. So I didn't manipulate, there wasn't one group versus another. I was just interested in what are the attitudes of year 11 IB students towards social media, and I gave you a survey, and then I collected my survey and I collated my results. Then that would be an example of just a survey. So I'm just getting data. I didn't manipulate anything. So a little bit tricky to watch that as we go through and try to determine, is it just a survey or is the survey just part of an experiment? So kind of check for that. A good example of a survey we looked at recently was the Park and Rothbard study, because they were asking people questions about sororities, but they didn't assign you to a sorority. So they were already in sororities and they were just asking their attitudes. So it was not kind of an experimental manipulation. All the data was just how did they express their attitudes towards other groups. So that's a good example of a survey, and a survey needs to have numerical scales. So I can get some sort of average. So numerical scales for a self-report. So I can say the average score was a 9 out of 10 on this factor. But the key we're just going to add here is it is not part of an experiment. So sometimes a survey is simply the way of obtaining the DV, but in this case it's not. It's not part of a separate, it is the whole study. So not part of an experiment, but the whole study is the survey. So again, you can think, is there any sort of clear IV? And if you're like, no, there's no independent variable being tested specifically, it is just testing attitudes of a group of people, then it's probably a survey. So that is our kind of third one for quantitative. And we are going to distinguish in a second when we look at questionnaires. So if it's a survey, I need to be able to give a number to your scores. So it's not open-ended questions. It's very much rank this. Okay, so those are my quantitative methods, and we'll talk more about strengths and weaknesses of them as a whole. I will say most of the time when we talk quantitative methods, the most common one specifically in this course is going to be a true experiment. So when we look at some of the strengths and weaknesses, a lot of times we're primarily talking about in the context of an experiment of some sort. Okay, qualitative methods. And the first one, observation, is going to be a similar thing to what we were just talking about before. So we need to be careful that there is no independent variable being manipulated. So if observations are just being used to gather the dependent variable, it is still an experiment. So we just did Bandura. So Bandura is an experiment. He said model, aggressive model, no model, all of that. He actually manipulated that, but they did use observation as the way of determining the dependent variable. That doesn't make it an observational study. The DV was in an experiment, just happened to be gathered by observation. If it was an observational study, it would need to simply be observing children at play and making notes about what you determined. So that would be an example of a more observational study when there's not any specific IV being tested, it's just observation of behavior. So if it's an observation, researchers observe behavior. And in doing so, they are looking to identify trends. And again, we're going to say no IV manipulated. So we want to make it clear that this is not part of an experiment. It is the whole one as itself. So generally speaking, the idea here is not to gather data on a specific thing. It's more generally just to look for trends. So you can think Bandura, he was like, check, 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 check. This is a more open, just identify trends that are taking place. Okay, so we're going to do a lot more, so if particularly for HL, but we are going to down the road go into like what are the different types of observations. So if this seems a bit brief now, we will talk a little bit more about them as we go. But for right now, I just want you comfortable with what is the method. So as we're going through these studies, you can identify which of these 6 it belongs to. And then just by knowing whether it's quantitative or qualitative, you can already start to have some of that evaluation piece. There's definitely some specific evaluations for each one that we'll build, but that's a good start. Okay, next is an interview. So an interview is essentially the researcher sits with somebody and asks them, and usually the questions are primarily more or less open-ended, so we're not saying like, give me this on a scale of 5, we're asking them for their experiences. So researchers ask open-ended questions to gain insight. This is what we would call a self-report method. S is a survey. So survey is self-report as well. So we have here. So this is another form of self-report. So observations are not self-report. We are watching and making the themed conclusions. In this case, we're asking people their experience. So that is interviews. They're used quite a lot in kind of socially sensitive research, which we'll talk about when we do our strengths and weaknesses. But there's a lot of things we cannot manipulate, but we can ask people their experience. So people that have had unique experiences, this is the opportunity to get information about their experiences, their kind of lived experience. One little thing, and generally I'm going to just advise you to stay clear of it, but there is a little bit of a loophole, so to speak. If the interview is written, so that's it. So when I said survey, I'm just like circle 1 to 7. If instead I gave you a paper that was like, describe your feelings about going into IB, describe for me what makes you feel like a successful learner, things like that were really open-ended, it's not really a survey anymore because it's not scaled, and it's also not an interview because I'm not actually asking you. So it is we're going to call that a questionnaire. So we consider a questionnaire for IB to be like a written interview. So in other words, it's open-ended questions. You could call it a survey, but then you're going to get confused. So we're going to try, if you read in thinking, they kind of use them somewhat interchangeably, but I think it's helpful to distinguish them. And generally in IB, they like the word survey for the quantitative ones. So if it is a qualitative written thing, we call that a questionnaire. Because a questionnaire in that context is kind of just similar to an interview, but removing the person reading the questions. So the responses are similar to that. I would probably not write about a questionnaire for that reason, because it's a bit murky, especially if it has some open-ended and some numerical questions. It would just kind of stay clear of that if I was writing a more detailed methods kind of question. Okay, and then the last one, which is also a bit of a strange one in that it involves often kind of multiple things at once, but a case study. So in interviews and observations, we're usually presuming that we have a relatively large sample, or at least a moderate sample. It's a group in some way that shares characteristics. A case study is an in-depth exploration of a small group, including a single person, or it could be a family, so it doesn't have to be just one person, but it's in depth, so it's usually over a period of time. A lot of times it involves some interviews, some observations. It could also involve some sort of experimental stuff as well if you wanted to see how they responded to something, but it's in depth over a specific individual or group of individuals that have kind of a key characteristic. So it's an in-depth study of a unique individual or individuals. So I read this book over the holidays, all about schizophrenia, and then I was really excited, but the IB doesn't include schizophrenia as one of the things they want us to teach on, so we're not gonna go down that rabbit hole, even though it was very interesting. It was about a family that had 12 children and 6 had schizophrenia, and so they did lots of studies on this family in terms of like observing behaviors. They did genetic tests on them, they interviewed the daughters, so it was an in-depth look at this family, because by having 6 children with schizophrenia, they presented kind of a unique family dynamic that was interesting for study. So that's a case study, and a lot of times it uses many methods within it. So that's another one to be aware of. So they might interview them and do some observations and even potentially do an experiment as part of it, or give them a survey. But if we really recognize multiple methods being done on a single sample, we would actually call it at that point a case study rather than identify one of the lone methods. So again, that's just kind of the introductory, but where I want us to be clear on is as we start going through our key studies, I want us to be able to, from the beginning, be able to say that is a true experiment, that is a quasi-experiment, that is a correlational study, that was a survey, that was an observation, that was an interview. So kind of identify those. A lot of the studies we do are going to be true or quasi-experiments. That's probably the most common category of here that we're going to look at. So we're going to see a lot of that, but it's good to have the others in mind as well from the beginning. Okay, I'm going to erase that, and then I'm going to go ahead and I'll make it with you. That'll be easy. We're going to do the next one. Okay, so next now that we know what goes in each category, we're going to do some overall evaluation. Now it's a bit tricky because obviously there's specific things that are specific to observations. They're different to interviews and so forth. So it's not absolutely perfect, but hopefully it gives you a general kind of framework for trying to evaluate this stuff. Okay, so if you'll notice, I was able to write fairly normally sized, so you don't need to write super, super tiny. And then the other thing is don't make the whole chart, like make the horizontal lines as you go. You can make the vertical ones, but that way you can just see how much space you need for things. That seems to be a slightly easier way of going about it. Okay, so I like to do the points here versus just random pluses and negatives. So this is what are we talking about, and then for each one. So for instance, we'll start with what is the purpose of a qualitative versus a quantitative study. And so you've already looked at these terms in your vocab, hopefully, so that makes that easy. And I have a few like reds just for like keywords, so you don't have to do the same, but just telling you the rhyme and reason behind what I'm doing. So the purpose of a quantitative study is to be a deductive approach. So when we say deductive, we mean we already have a theory, therefore a hypothesis, and we are testing that theory. So we are supporting or refuting an existing theory. So the theory already exists. From the theory, we've made a hypothesis. And from that hypothesis, we are now going to do research on. This is a really important purpose of research because we want to provide evidence and check that the theories that we're saying are actually accurate. However, sometimes we do not actually yet have a theory. So in that case, we might do a more qualitative approach for an inductive study. So an inductive study is often the first step, where before we can come up with a theory, we do some observations and look for themes to try to guide the theory. So instead of just immediately going in with this is what's happening, we're just trying to establish kind of recurring themes for that purpose. So the purpose of these are usually to establish theories. So if we go back to the example we did during transition, we would talk about like, well, Festinger going into the cult, he was just looking at why do people do this? You know, he didn't have an existing theory yet. He was just gathering information. And then once he made the theory, he then tested it with his $20, $1 study to say, given this theory, does my research support it? Okay, so that is the general purpose. And again, that's not perfect because we certainly know of like Bandura's experiment, which was an experiment, but was still kind of in the early stages of development of the theory, but he already had a hypothesis. So that's another way you can think of it. So it's support theory. I'm sorry, I made you draw the line. You don't have to write this. I just came up with it then. But it may be that you don't have a theory yet, but there is a hypothesis being worked, and so you're testing that. Okay, next thing I want to talk about is how is the data used? So when we actually gather numerical data, the purpose of the data is usually to then work out some sort of kind of mathematical means, so do some calculations, some statistics, and then do what we call inferential statistics, which means we actually plug it into a program that tells us, is the difference between these conditions statistically significant? So we are able to come up with essentially an objective mathematical way of saying they are different enough. And then if we do that, then we usually can say, therefore, I'm confident that this caused this because the difference is significant as long as it's a true experiment. So the goal here is some sort of statistical analysis. So we are gathering numbers to then, we're not just gonna have a set of numbers. Like, here's some numbers that I came up with. We're usually gonna do means followed by tests for statistical significance. So you can usually do tests for statistical significance. And that's gonna tell me how valid the results are. So we do the test for statistical significance, and that allows us to like support or not the hypothesis. So for conclusions. So again, a bit tricky kind of trying to go in this order in the sense that like there's a lot more to say about that and it's in the booklet. So we will pick up more with statistics, but right now we're just gonna clarify that there are tests that are done on it. And then the goal, ideally the gold standard, is to determine cause and effect. So if our results are statistically significant, then the purpose of that is to be able to attribute cause and effect. We are going to remind ourselves that that is only the case in true experiments. So if we did not manipulate an IV, we actually cannot determine cause and effect, but we could concur that there's a significant relationship. So we could say there's a statistically significant relationship between these two variables, even if it's not cause and effect. If we have qualitative data, we still want to analyze it in some way. So we don't want to just sit there and have all these journals of all my observations and interviews. So generally what's done is called content analysis, or inductive content analysis. So the purpose of content analysis is usually to then go through all of this descriptive data and look for recurring themes. So we're trying to find what showed up a lot. So we're not trying to do an absolute mean or anything, but we are trying to identify recurring themes throughout it. So if I interviewed each of you and asked you questions about your study habits, your feeling about IB, your social media use, all these questions, then I would want to then take all of your responses and say, a lot of my students mentioned to me that they really wanted to do IB because they like being more independent learners. Check. And I might say, oh, but I also had several mention that they were anxious about the extended essay. So I would just be looking for what was frequently occurring. So I'm not saying my goal is not to say this caused this. I'm just saying what are some common things that came about. So I'm usually not intending to attribute any sort of cause and effect, but if I'm gathering this data, I don't just want pools of data, I want to come up with some sort of conclusions from it. All right, so that is what we are doing with the data. Next, we're going to say what kind of depth of understanding is this method giving us? So introducing a new term that we're going to use kind of sporadically, but one of what we're trying to do with an experiment in particular, and again, any of these, is we're tending to try to isolate single things. So one IV, what does this have to do with this? And that's great if we want to try to determine cause and effect, but a lot of times in the process of doing that, we're often like oversimplifying it. So we're like, I want to determine how exercise impacts sleep, and I can manipulate how much you exercise. But in doing so, although I might be able to help really unpack the role of exercise, I'm potentially ignoring a lot of other things that also impact sleep. So I'm being too specific. I'm reducing a complex issue to one IV. So when we say that's a negative thing, we say that's reductionist. So I'm taking a big concept and I'm reducing it quite simply to a single factor. So the problem with quantitative studies is they tend to be very specific, and that's intentional. So often they're looking at a single IV. Sometimes they might look at a couple of different IVs, but they're looking at quite specific things. And so our negative term for that is that they can therefore be quite reductionist. So they're not giving me the full picture, they're overemphasizing on one thing. Qualitative studies, on the other hand, tend to be much more holistic. So instead of saying, I made you exercise, I made you not exercise, then I recorded your sleep from your watch, I would be saying, share with me how you feel about your sleep right now. Okay. Oh, how do you think this impacts it? I might be like creepily watching you sleep, hopefully not. But the point is, I'm actually doing some sort of kind of whole issue approach. So this is giving me kind of rich data. So I'm not just getting one area, I'm getting a lot of data that helps me to fully explore a topic. And this is a more holistic approach. Now I say it's more holistic, again, this is generally speaking. It's also possible to be doing interviews that are way too specific. So in general, this would allow for a more holistic approach. But if I interviewed you for an hour and I just asked you over and over about your exercise, like, well, how many exercises did you do on Tuesday? What kind of exercise? Did you do weights? I might still be being quite reductionist if I'm choosing, but generally speaking, these allow for us to actually be a little bit more broad in what we can cover. All right. So now we're going to start to get to some things that are more strengths and weaknesses. But again, instead of just listing strengths and weaknesses, I still want to go through them kind of specifically. So we want to go through and look at each in terms of their objectivity, their generalizability, what they can actually study, and then reliability and validity. So we're now looking a bit more evaluative. I guess this one kind of was as well. But looking at some of the terms again that are kind of saying the benefits versus costs of these. So one of them is the objectivity. So remember, objectivity is basically saying, could any two people look at this and be able to come to the same answer? So if two people would both look and say, oh, yep, I came to the exact same answer, that would be more objective. If there's a lot of individual interpretation, we call it subjective. So in most cases, quantitative studies are objective, which means they are there is a common answer. So basically there is kind of not up to interpretation. So if I were to give you I went into the next box. If I were to give you some survey results and I gave half to you and half to you and I was like, please add them up and calculate the means, that's not going to be requiring any sort of your individual interpretation, and you should both be able to get the same results. So they are usually high in objectivity. Not perfect, so there are examples where that is not the case. We have to be really careful not to oversimplify. Even things like Levine's study, when they were walking across and someone fell, there's a little bit of well, what counts as helping? If you just shout, "You right, mate?" Is that actually helping? So even sometimes it's not super clear, but in general, it is supposed to be higher. The problem with here is that these tend to be highly subjective. So it requires the observer or the interviewer to make some sort of call themselves about what that means, particularly because of this, because we're looking at these themes. So who determines what a theme is? So get a whole bunch of data, who determines the theme? Along those lines is the problem that whoever is determining those themes might be biased in some way. So if I asked you questions all about your favorite classes and gave an hour-long interview and I asked you, what classes are you enjoying? What are you not enjoying as much? And then I was the researcher, I might be like, a reoccurring theme was the love for psychology. A reoccurring theme was they really liked teachers who made tables. It was a really important theme. And that might be because I wanted it to be a theme. So I was looking for it. So kind of confirmation bias. Every time I saw it, I was like, oh yes. So the problem with these highly subjective things is they tend to be prone to what we call researcher bias, where what the researcher thinks and what the researcher wants the results to be comes out in the results. So that's a little bit harder. If I gave you a scale and I was just rate all your classes on a 1 to 7 scale, it wouldn't be quite as possible for me to skew the results by what I wanted. It'd be a little bit more objective. Well, they rate psychology 6, they rate chemistry 7. Clearly, I get the point. Whereas if I just ask you, I might kind of have a different way of interpreting it. So that is the issue with objectivity. The next one, which we've kind of used this word, and then we're going to have to talk more about this as we go, but generalizability. So generalizability is this idea of, does this sample's results mean anything to the population? So generally speaking, if you have quantitative data that you have done a statistical test on, if your sample was representative, then yes, you can say, because I'm saying this is statistically significant among these people, as long as they're representative, then I can generalize it to a population. So, can generalize results to a population? Just trying to keep the keywords. So, can generalize results to a population if the sample is representative. So if the sample, we just have to consider who are the sample and what populations are they a fair representation of. So we might say, okay, yes, I could probably generalize that to children in America, but not all people everywhere. So there's still some limitations. In this case, because of the fact that there isn't this kind of clear statistical analysis being done, and there's the subjectivity, we generally say it's difficult to generalize. So we don't have a way of saying for sure that it's significant. It's really rich data, so it becomes really difficult to do. So generally speaking, we say that it is not possible to generalize without statistical tests. So it's too kind of nuanced to actually be able to do that. There is one little exception, and that is that you can't generalize to a whole population, but sometimes you can transfer those findings to a similar group. So if I did all these interviews with people that have recently given up smoking, and I asked them for all of their tips and findings, and I grew all this data, I couldn't necessarily say that for the whole population, but I might say, hey, this information was really helpful in this group. If you had another group of people who are similar age who've also given up smoking, you might want to look at these findings. So there is some degree of transferability where we can transfer it, not generalize. So generalize is like going this and going, everyone. Transfer is going this to this. So we're transferring it to a similar small group. We're not generalizing it across the board. So transferability to similar small populations might be possible. We are going to talk about generalizability and transferability. And again, like just if you're like, oh, she's just going so fast, I'm never going to get information about this. It's in the booklet. So we will be doing a whole lesson on generalizability. So I am introducing important key terms right now. But I do know that we're going to need to go through each of these and actually discuss what they mean as we go. Okay, so you should be like, I don't know, like somewhere around 2/3 of your page through. I'm going to erase, but I only have like 3 lines left. So we're most of the way through. All right. Okay. All right. So the next thing I want to consider is like the scope of what you can actually look into with this method. So the scope of topics to explore. So when we're doing an experiment, we have some issues. So especially if we're trying to do a true experiment. So if we are really trying to really look at this effect on this, we're often looking at things that we're able to manipulate both practically and ethically. So if I just gave my example of like how do people cope after giving up smoking? It would not be ethical for me to be like, I'm gonna need you to smoke for a week, and then when you give up the smoking, I'm gonna need to observe your behavior and check how many times you did this, this, and this. So that wouldn't really be ethical, and there's some that are just not practical. So if I wanted to be like, I wanna see how people cope after they leave a doomsday cult, I can't be like, hey, if you don't mind joining this cult for a while and then come see me afterwards. It just wouldn't work if you try and manipulate it. So when we look at quantitative methods like an experiment in particular, we're often limited in terms of what we can actually study. So we're limited to kind of topics that are able to be manipulated both practically and ethically. Again, that's probably more true for experiments. So I might even clarify that. Because in theory, you could do a survey for more topics. So experimentation is limited to things that can be manipulated easily and ethically. So there's some things that are just really difficult to manipulate, and then there's some things that maybe we could manipulate, but we shouldn't manipulate them. So that somewhat limits our scope of what we can use experiments to study. Qualitative methods are better if we want to study socially sensitive topics. So if we want to study something that is like the impacts of like childhood neglect. So again, not something we can manipulate, but we could do some interviews. We could do a case study. So we could really dig deeper. We could do some observations in a creche to see how kids that are coming from certain home backgrounds. So we could use qualitative methods to gather information on complex topics that are already existing. So these generally allow for the study of socially sensitive research. Because again, we are not manipulating anything, we're just observing or interviewing or discussing things as they've already occurred. So socially sensitive research is often done via qualitative methods for those reasons. All right, the last two are reliability and validity. So reminder that reliability, when we say reliability, we mean the likelihood of gathering the same results over time. So essentially, so a very quick version of it is if we say a study is reliable, it's because it gives you the same results. So these studies, quantitative, are really good for reliability because they have a lot of usually standardization and control. So even if we were looking at something like a survey, it's usually a set survey. We could just give it out to everyone and keep collecting the same results. So the studies are usually able to be easily manipulated. So replications are easy. And we're going to say easier because, again, there are some experiments that are more complex in design, but generally replications are easier due to standardization, which means the goal of trying to do it the same way each time. And the maths behind it, the statistics, allow for comparison. And so all of these things allow for an increase, or at least allow us to determine reliability. So those things don't in and of themselves give us reliability, but they make it possible to determine whether our research is reliable or not by doing that. Okay, for qualitative, it's actually really, really hard often to repeat for a couple of reasons. So first of all, a lot of qualitative research is really time demanding. So if I'm doing particularly interviews, so if I'm going to sit with somebody and ask them all the questions, describe all the answers, then do content analysis, we tend to run into the situation where it just takes a long time, so we don't do as many replications, or in some cases, the situations are too nuanced. So if we are looking at kind of case studies, it's really hard to find similar studies. So in this case, research is often time consuming. Or the situations are quite nuanced. So it's usually very hard to create meaningful replications. So it's very challenging if I'm doing an observation and I'm looking at how children behave in this setting. A lot of times the next day we'll have a whole different kind of set of vibes. So even if you're trying to repeat it, you may find that you're not able to kind of get the same situations. So making replications difficult. It's not impossible, particularly with things like interviews. So in theory, with an interview, if you had a set number of questions, you could interview people 1 year and then you could interview it again the next year and kind of compare it. But also, again, because we don't have any statistics, it gets hard to work out if the findings are the same. So you don't have kind of a baseline for comparison. So it makes it difficult to say whether the results are reliable or not. Okay, last one is validity. So this is a bit oversimplified because it really does depend on the type. So we'll kind of break it down into type. Remember, valid is basically saying like how true to life are the results. Do they represent true things? It's a bit tricky. It makes more sense almost to me, validity, if you talk about it specifically. So we're just going to mainly look at the two contrasting ones, which I think is the easiest way to go on this one, which is our internal validity and ecological validity. So when we are talking about an experiment, particularly, what we are usually doing is increasing our internal validity. So we're saying our internal validity is higher. So we can increase our internal validity with more control. And also remember, it's highest if we manipulate the IV. So in this case, we can manage to control quite a lot. So that makes the internal validity high. Sorry, I should. Again, so our high internal validity. But remember, when you do that, when you start doing a lot of control, pulling people out of their kind of more typical environments, making them do something that's unusual for them, we usually do that at the cost of ecological validity. So generally speaking, ecological validity is lower. And that's usually lower due to the artificiality and simplicity of the tasks. So a lot of times, again, because we are trying simplicity. I can't spell. Maybe that's right. Because we are trying deliberately to simplify it, to really focus on one thing, it no longer represents kind of the way, the true nature of things. So our attempts to oversimplify things reduce our ecological validity. Again, this is like a generalized statement because field experiments, for instance, can flip this, or some field experiments can do a good job of trying to manage both. So they can have a fair amount of control while also doing it in an environment that's more authentic. So not true of all, but this is a generalized thing that you have to watch for when we're trying to do these highly specific numerical based experiments. We might be compromising our ecological validity. And then again, this is going to basically be the opposite. So in this case, we're going to increase our ecological validity because generally speaking, we are now looking at either authentic situations or giving people a chance to report. So this is generally high for natural environments or self-report. So it kind of goes back to if I was studying sleep, one option if I was doing an experiment would literally be to make people come and sleep in a sleep lab and record all these measurements. But of course, by the time I'm doing that, they're no longer in their home environment. So if we were to instead do like an observation, again, creepily watching people sleep, not a weird example, but that would be more realistic. Or I could just ask people, how do you feel? Do you feel like you're getting quality sleep? And again, that would be more authentic to their like lived experience. But in general, these are going to have very low internal validity. And generally speaking, when we get to this at an HL level, we'll actually say that we don't even use the term internal validity. It's basically implied that it's so low when you have no IV and DV. We're going to use the word credibility instead. It's just kind of a different terminology to accept the low validity, but say, does it still provide some sort of authentic meaning? But that's a little bit much for today. So we'll just state for now that they generally have quite low internal validity. And that's because, again, they usually have very low control. So another way we can say it is they have lots of extraneous variables. In other words, there's too many things going on. And again, it's so low in this case that almost the term doesn't mean anything. Like they just don't have any internal validity, but that is intentional. So like I said, we'll kind of replace that with other terms as we go and say, yeah, no internal validity, but they can still have credibility, which means they're still presenting meaningful findings, even though there isn't any kind of control. There's not supposed to be. Okay, so that is all things research methods. So hopefully that gives you a really good start for now as we start going through research studies. You can feel like you can identify the type and start to think about what are some of the strengths and weaknesses of them. And like I said, a lot of this we're going to pick up in more detail as we go. We'll do experiments like in a week or so, so we'll go through more detail on the types of experiments. So that is to come. For right now, hopefully the very brief reminder that true is manipulated, quasi and natural are not, will get you through to when we go into a little bit more detail on that. You probably have a handful of minutes left now. So with the handful of minutes that you have left, I don't even think I brought my other booklet, but if you have your sociocultural booklet, you can start looking at the key studies for stereotypes. So one of them is Hamilton and Gifford, which we actually did the simulation of with person A, person B. And then the other one is Park and Rothbart, which we have already talked about, but you could go back through and write what was your conclusion and link it to stereotypes really specifically. So that would be, if you have a handful of minutes left, you can work on that. Otherwise, don't forget to have a look at your questions for tomorrow so that you're prepared to share with us your thoughts. There are no right and wrong answers, so they're open-ended questions. So it's more just to get the critical thinking wheels going, and I'll see you in the morning. Bye.